In this next video, we'll be solving the equation 2 sine squared x minus 3 sine of x plus 1 equals to 0. This particular example is a little bit heavy in terms of the concept that when you look at it, it is not just a singular trig function. So we can't just solve this like all the other previous examples that we've looked at. What we're going to have to do is implement some of the algebraic methods that we have been able to use effectively in manipulating trigonometric expressions. One of those methods that might help is to view this equation as though it's no longer a trigonometric equation, but simply a algebraic one. You'll notice that in this case I've replaced all my x's with, all my sine of x's with simply x's. And by looking at this equation, I should argue that it is a quadratic. So sometimes it might help for us to view these equations and these trig functions inside of them as though they are actually variables in and of themselves. So this equation right here, if I were to attempt to solve this, I would use again factoring, in which case I need to find two numbers that will multiply to get me 2, but add to get me a negative 3. Those two numbers will both be negative 1 comma negative 2. And I will tear these numbers apart, giving me 2x squared, bringing this one down into a minus 2x, and minus 1x, and then plus 1 equals to 0. Again, notice how I just carried down this term, and left those two terms in the middle to separate based on the numbers that I found over here. I will then use grouping to factor this out, giving me 2x and x minus 1. Over here I'll factor out a negative 1 so that the sign switch of x minus 1. And then you'll notice that x minus 1 and x minus 1 are the same, so I have 2x minus 1. That's this piece grouped with this piece as one factor, and x minus 1 equals to 0 as the other. Now, some of you might be able to look at this equation up here, recognize that it is in a quadratic form, and therefore we're looking at something that looks like this. As though you factor it, I'm going to cross this out because, again, mathematically it's not appropriate since our x is inside of a trig function. We should note that this is then 2 sine of x minus to 1. That's that first factor, transition to the sine function. Sine of x minus 1. That's our second factor, transition to the function. And if this was an actual quadratic equation, we would set each of these pieces equal to 0, 2 sine of x minus 1 equals to 0, and solve for the variable. And again, we're going to treat sine of x as though it's the variable. So I will add 1 and then divide by 2, giving me sine of x is equal to 1 over 2. You'll notice that in this case, I'm looking at the unit circle to find the values where sine of x equals to 1/2. Don't forget the secondary piece where sine of x is minus 1 equals to 0. That's going to give us sine x equals to 1. So again, one more time, based on these two situations, we're going to return to the unit circle. We're going to find the locations where my sine function is equal to a 1/2, which is going to be pi over 6, as well as 5 pi over 6. And we're also going to find out where the sine function happens to be equal to 1, which happens to be pi over 2. So for the sine of x equals to 1/2, my x value ends up being, again, pi over 6 and 5 pi over 6. Those are the two solutions that satisfy this equation. Those two solutions will satisfy the original equation because they satisfy this factor of that equation. When I'm looking at sine of x, again, x is going to be equal to pi over 2. This provides me with the solution for this equation. That solution will also satisfy this factor equaling to 0, and therefore will satisfy this original equation. Now we should again check all three of these solutions, and they do end up checking out. Again, by plugging them into the original equation, we plug them in very carefully. I'm checking simply the pi over 2 case. This should provide us with a value of 0. Well, I'm going to have sine of pi over 2, and the sine of pi over 2 is 1. 1 squared is 1. And that's going to give me 2 times 1, minus 3 times 1, because sine of pi over 2 is 1, plus 1. You'll notice I have 2 minus 3, which is negative 1, plus 1, which is 0. And this does check out. Those three solutions will satisfy this quadratic form of a trigonometric equation.